Good afternoon, class. Today we're going to be talking a bit about tile maps and how we can create a tile map in XNA. So by this point you should have read through the textbook chapters discussing a tile map, which is really just a 2D array of tiles. And now we have a starter project we're going to be working from. We have a very simple tile set, which has 4 tiles to it. Each of these tiles is 64 bits by 64 bits. And then we have a map file, which is describing our map. And we have a couple different values in here. I'm going to add one more. I'm going to actually add the tile set for the name of the file. And the second line is the width and height of the file separated by a comma, and then the third line is the width and height of the map in terms of tiles. And then finally we have the actual tile indices themselves. And these start at 1 being the tile here, 2, 3, 4. And that's really everything we need to kind of get started in terms of the actual data we're going to want in here. And then in our project, we're going to go ahead and create a class to represent that tile map. And this will be actually represent any arbitrary tile map that uses a tile set image file and a tile text file like the map that I just showed you. So we'll create a tile map, and we need certain data to actually know the details about our tile map and pull these together. So one of the pieces of details we need to know is the tile width and the tile height and the map width, the map height. These are all important for the math involved in creating our tile set. We'll also need a texture for our tile map texture, or tile set, actually. So this is the tile set texture. And I am just making these as fields, private fields. And we need the XNA framework and the graphics package of that. And in addition to the tile set texture, we need a list of tiles. And if we think about what information we need for the tiles, we need to know what texture belongs or they're using, which we're just going to use this one. And we need to know what their bounds are within that texture, which can be a rectangle. So actually all we really need to represent our tiles right now is a single rectangle for each one. So rather than using a rectangle, we're going to use a rectangle array to represent that. Now, in a more advanced setting, we might need some additional information, like if this tile is supposed to be a solid tile, or if we're doing a platform, and maybe it's a platform that you should be able to jump through. So we might add, instead of a rectangle, we might actually have some kind of struct or class that we're using here. But in this case, really all we need for this very simple implementation is just those rectangles bounds. So that's what we're going to do there. Then finally, we need the actual tile indices, which we're going to store in an int array, and I'm going to call that map. Okay, so these basically form the core of the information we need to load and process our map and actually display it. Let's go ahead and add a constructor. And I'm going to add in the constructor a string file name, and that's going to be the file name for the map that we want to actually load and use its data in our game. Let's go ahead and store that one as well. So we'll go ahead and set file name equal to file name. Store that, which brings us to our load content. And here we're going to need a content manager. And this is going to be, in order to bring that content manager in here, we need the Microsoft.xna.framework content manager or content namespace. And notice now we have the content project or content object, and we can go ahead and walk through loading up this file map, for which we need also the system.io. So in this case, we're going to be using the standard system IO libraries. Now, this will work fine on a Windows machine, but if we were to compile this for, say, one of the game consoles, it actually becomes problematic because there are certain aspects that we're not allowed to use that library because that is not implemented in that particular environment. They use a different set of libraries. So normally we'd want to use some kind of abstraction, or we'd want to build this file through the content pipeline so that we'd have a binary file that's very specific to our game that we could then load using the content manager. And we'll see how to do that in a future lesson, but for now we're just going to go ahead and load it from the file system. So the first thing we need to do there is open up and read that file. And I'm just going to use file.read all text and use the path.join content.root directory. So this is pointing to this content directory, and then we're going to pull map.txt out of that, which is hopefully the file name that we saved here, that private one. Whoops. Type in the right spot. And notice that I'm not using the asynchronous version here or anything fancy like that, because basically we can't do anything with the game until this is loaded, so it's okay that this is potentially a longer blocking process as we pull in that data. And from there, we're going to create an array of strings called lines, which is just going to be this data.split, and I'm going to split it on the new line character. Now, because this was actually written in Windows, it actually technically is two characters, the /r, the /n, but I'm using the Linux version, or just the new line character here instead of the carriage return new line character sequence that is more normal for Windows, because it's not going to matter the way I'm loading this, and I'll show you exactly why. For the first thing we're going to do is we're going to get the file set, tile set, file name, and that's that very first line, which is this tile set. Now notice we don't have the .png because we're going to pull that one in through the content pipeline. And because we didn't split on the carriage return and new line characters, after we do grab that line, there's still technically a carriage return in there, and there might also be some white space. So we're just going to go ahead and do trim, which will get rid of all of that. We'll just have the file. So that takes care of that one. We want to go ahead and load that tile set texture using the content pipeline. So we load it just like we've loaded our other ones. So this is a texture 2D, so just like we've done in prior exercises. And we're going to use that tile set file name to identify the texture that we're loading. And our second line is the size of our tiles. Remember, it is a string with a comma in the middle, x, or the width, and then the height. So we're going to go ahead and pull that out. To do that, we're going to need to split this line on the comma. So we'll call this second line equals lines 1 dot split. We'll split on the comma character. Again, because I have a space in here, that's going to technically leave a space 64 on that second line. So we could either go back and remove all our spaces, which makes it a little less readable, but it actually doesn't matter because we're going to set our tile width to be, and remember this is an int, so we have to do int.parse. And int.parse actually will take care of any white space that's there. So we can just say second line 0, and that will go ahead and take everything up to the comma, which was 64, and then we do the same thing for tile height. We're going to grab the second set of characters, which is going to be that space 64, but int.parse goes ahead and throws away any white space. It just focuses on the numbers, so that should succeed as long as our file's in the format we expect. The third line is the map size, and again, is it just a pair 10, 10? So we basically deal with it exactly the same way. Pair third line and we have map height, and map width actually should come first. Third line 0, and we need to parse that as an integer. And dot parse third line, put 1 in there. So that gives us our map size. So now that we know how big our map is and how big our tile set is, we can go ahead and initialize the information about the tiles and about the map. So actually, let's go ahead and initialize our tiles here. And what we're really going to do here is just compute the number of columns. In that tile set by taking the width of the texture, which remember we've loaded right here, so we can say tile set dot width, and dividing that by the tile width that we've come up with here. And what that's going to do, because this is integer division, and that's going to give us the total number of tiles that can fit in that texture that would be an entire tile. So if we have a little space after the edge of the tiles, that just gets thrown away. In this case, the tile set is exactly double the size of a tile, so we're using the full image. But if your tiles had some other constructions, if they had a little bit of padding around the tiles, this is where you'd have to deal with that, and you'd have to probably modify your tile map text file to describe those additional details. We don't have to do any of that because the tile set we have is very, very simple. The rows are computed pretty much the same way. Tile set texture dot height. I don't know, I've got those turned around. So it's the tile set. No, that's right. Tile set rows, tile set columns, height divided by tile height. Alright, so that gives us the width and the height of the image, or the number of tiles in the image going vertically and horizontally, and those of course correspond to our tiles array. So we're going to go ahead and create a new integer array, and that needs to be that size, which is tile set columns times tile set rows. These should both be 2 based on the calculation, so we will create a new int array, or rectangle array, that's going to hold the bounds of those individual items. Alright, and we can go ahead and even calculate from what we know about the file what the bounds actually are. So we're going to start with a for loop, and we're going to use the y, and we reverse these like we talked about in the textbook because it helps us avoid cache misses, which means we're going to actually be running a little bit faster. So y is the tile set columns I plus plus or y plus plus, and just an instance variable for x equals 0, x is less than tile set rows, and x plus plus. So we iterate through both dimensions, and from this x and y, we can then determine exactly what the rectangle coordinates should be. Let's go ahead and create an index. And this is done, this is converting our 2D coordinates into 1D coordinates. So our coordinate here would be y times tile set row columns columns plus x. And then we can go ahead and say our tiles array at index is going to be a new rectangle. And we need to define the x and the y of the upper left-hand corner of the rectangle, or the first two arguments. So our x would be x times the width of a tile. Because remember, we're doing pixels. So the very first tile is going to be at 0, 0. The next tile is going to be at the width of a tile 0. So that's going to be the x and the y. We're going to do the same thing with the tile height. And then we need the width and height of a tile, and all of our tiles are going to have the same width and height. That's one of the standard properties you would expect from a tile map. Okay, so that will actually, through iterating through the x and the y, we would actually initialize all of those tiles to have the right bounds. So then we load in our map size, and once we've loaded in our map size, we have the information we need to actually create the map. And so our map is an array of integers. So we're going to create that array, and the width is, or the size is going to be the map width times the map height. That's the number of tiles we need to store. So that's pretty straightforward once we've loaded those in. And then we're going to do a very similar loop to what we did up here. We're going to iterate over the map now instead of the tile set. So we're going to go for int y equals 0, y is less than the map width I plus plus, or y plus plus, and then int x equals 0 inside another for loop. X is less than the map height, x plus plus, and Visual Studio would behave for me. There we go. So again, we're iterating through, and we iterate across the y and then the x to avoid cache misses. That just becomes a standard pattern you want to use when you're doing this kind of work. And actually, I don't even need to do x and y. We can just do I and take the map width times the map height, because we're already a one-dimensional array. But we're a one-dimensional array of what's being processed as strings. So we want to convert that into integers. And that's actually the fourth line. So var fourth line equals lines 3 dot split. And we're going to again split on the comma. So if we look at that tile set, or the map.text, you notice that they're all comma delineated, and it's just a 2D array, which is why we could just do the simple for loop. But that 2D array should be the width of the map times the height of the map, in this case 100. There should be 100 entries, and we want to actually set the map entry at that index to be int.parse fourth line at the corresponding position. So basically each index, because we create an array, a one-dimensional array, this fourth line from splitting that string, those are the string equivalents of the numbers we want to store in our map. So that's what we're doing right there. And once we finish that, loading that process, we are ready to write our rendering. This is going to be a draw method. And I'm going to go ahead and take in a game time. We don't necessarily need it, but we're following the standard pattern of X and A. And then we're also going to take in the sprite batch that we're going to use to draw this map. And we're going to assume that the sprite batch begin and end have already been called. So all we really need to do in here is render the actual map. And this one, we do want to have two loops because we're going to use the x and y coordinates. So we're going to start with, again, int y equals 0. Y is going to be less than map height y plus plus. And then inside of that, we're going to do our for loop with the x. And do map width. And finally, inside, we're almost ready to do our drawing. We need to figure out what our index is. So that's going to be extracted from our tile map. So we can do y times the map width plus the x to convert from 2D to 1D coordinates. And then, if you remember, our map actually starts counting at 1. But our arrays always start at 0, or indexed at 0. So we're going to do an extra step here. We're going to take that value, we're going to subtract 1. Or we could change our file structure, but this is the file I had, so this is what I'm working with. And then we also want to check that that index is not equal to 0. Because if it's equal to 0, that actually, or actually -1 at this point, because 0 was meant to indicate that this is not a tile to draw. It should be transparent. So if we subtract 1 from 0, we'll be at -1. So that means this is not a tile to draw. So we can just use a continue. And that continue says break out of this loop, come back and continue in this loop. So we or actually just skip over, this loop, continue. It's not a break. So we just skip this one increment through this loop and we move on to the next. So if that happens at x equals 5, we'll immediately look at x equals 6. So if we get past that continue, that means that we are going to want to draw this. So we'll create a sprite, or call sprite batch dot draw, and we'll pass in as arguments our tile set texture and a vector, which is the position we want to draw this tile in the world, and then the tiles at index. So what are the bounds going with this particular tile? So is it the first, second, third, or fourth? And the final argument is color, and we're going to just use color.white. Okay. And we have to go back and add in our vector position, because using this constructor gets us always the vector 0, 0, which is not what we want. But where should this be positioned in the world? That's a very good question. And the answer is we are going to use the x value, and we're going to actually just compute it. So given the x of tile coordinates, and this is what we're working in, tile coordinates, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 are the coordinates of the tiles in the map. But we need to turn that into world coordinates. So we have to transform that. We take that x value, we multiply it by the width of a tile. And that tells us how many pixels over each tile is. So tile 0 is at 0. Tile x equal 1 would be at tile width times 1. And then x equals 2 would be twice the distance over. So you just basically keep adding the tile width. And then we do the same thing for the height. And this is one of the nice properties about tile maps, is we really only need a small amount of information to actually figure out where the tiles go, where the bounds go. All of that kind of information is pretty much derived from really just these variables are all we really need to be able to do that. The width of the tiles, the height of the tiles, the width of the map, the height of the map, and then the width and height of the actual image, which we're pulling out of that texture 2D. So this is really all we need to get a simple sprite batch based tile map up and running. Let's go ahead and do that. Now there are a couple things we have to do over here. First of all, our content project, we want to open that one up and make sure that we've added the image to be processed. So we go to MCGB editor, WPF, and it'll take a little moment to load. And we just want to go ahead and add the existing file that's already in our content project, tileset.png. And we can go ahead and build that, and you can see that tileset built just fine. So the image is fine. Now the map we are not going to be processing through the content pipeline. I'll show you how to do that later. But what we're doing today is we're just going to load this from this file. Except we're not going to load it from this particular file. We want to load it from a file that's in the content folder of our build. So if we right click on this map.txt and go to properties, notice that it tells us copy to output directory is set to none. Output directory is that directory that our build is dropped in, that binary directory that we've been turning in. And that's where our content files are going to end up. They're going to end up in there as X and B files. Well, we need this file as well. So we need to either do copy always or copy if newer. And normally we'll want to use copy if newer, which just means when we make changes, those get overwritten in that directory when it builds. But it has to be there, or we're going to get an error when we run this where it can't find the file. And of course, that file then needs to be distributed with our game as well. So let's go ahead and run this and make sure it works. Well, we haven't actually loaded our tile map. We just created the class to represent it. So let's go ahead and add a tile map into our game itself. So we need to create it. So we're going to construct it. And in this case, actually, traditionally this would be done with X and A in the initialize. And we can do it there because we don't need to have the content manager loaded. We don't need graphics set up to construct the tile map. Remember, all constructing the tile map does is save the file name, which is going to be map, and we leave the text off. Oh, no, we do need the .text because this is not a content file. It is just a regular old vanilla file that we're using. And then load content is where we're going to actually invoke the load content of the tile map, which will actually load the texture at that point, which is why we need to wait for this. And we have to provide the content manager, which is just the content property of the game itself. So we pass that in. And then we don't need to do an update because we don't have an update in our tile map yet. If there's some reason you need to do update logic in your tile map, you can certainly add that. And then the same for drawing. We can go ahead and do tilemap.draw and pass in our game time and our sprite batch, which is a private field in this class, so we need the underscore in front. And now if we run it, we should actually see our tile map being drawn. Oh, except we have a spritebatch.draw call that is not inside of a spritebatch begin and spritebatch end. All right, try that one more time. And now you can see our tile map is being rendered. It's pulling those tiles out of that tile map and putting them on the screen. And there are, of course, lots of things we can do. We've already learned about sprite batch transformations, so we could apply a transformation matrix here. Let's do a translation matrix. I think we get with matrix dot create translation. We're going to give it next line is Z. Let's put this maybe 23, 23, and 0. So that should translate it in the X and the Y. And if we run this again, you can see we've now shifted the map down and over. So you can shift the whole map. You could have passed in an offset vector to the draw command, but because we're using the sprite batch, we can also use all the same sprite batch transforms that we saw before. So there's a lot of flexibility there. As far as the draw goes here, we could also do things like if we wanted to have animated tiles, if we wanted to swap tiles every now and then, or swap the bounds, or reverse them, flip them, use spritebatch.draw and pass in a flip or something. We can do a lot more than we're doing here in this simple example. But this gives you kind of the starting point where you can go ahead and start building out a very interesting game engine pretty simply. Now, a little bit later in the lecture, or in the textbook, we also introduced a different approach, which is using a tile map created by the tiled map editor. So this is an example of what one of those files looks like. And it has a lot of different ideas as to how to organize maps that are a bit more complex, but it adds a lot more functionality. For example, maps are organized into layers, so we have multiple layers, in this case 2 layers, which have their own data. And this is just the same as that comma delineated list. The difference is this is encoded in base64 and then compressed using the gzip library. So these are ways of taking large text data and squishing it down so it doesn't take as much space. We also have the concept of object groups, where we can define objects in the game world that aren't tiles. So these could be used as spawn points or other things like here. This is being used to set where the hero is located in this particular game. And then when it gets loaded in, it would actually deal with positioning that player. And this actually gives us also a very straightforward tile map when we run it. And the nice thing is we can actually create this tile map in that map editor, and that's a lot easier to do than by going in and tweaking things by hand, or even writing this file by hand. This is done with the tiled map editor, and you can see here this is exactly what the view that it gives you. So here's the map that was drawn, and you can see there's 2 layers here, and we can hide the tile maps rule layer and see that. And notice that they have an object layer called events, where they put the hero and some other information, and that gives, for example, the some of that information is used to define that this layer should change its opacity over time. So you can see it's kind of fading in and out. And if you dig into the example game that goes with this, you can see in the update, they're pulling out this information from the object groups to actually change the opacity of that layer, as well as position the hero on screen. So that's a more complex example you can take a look at if you want to use the tiled map editor. And next week we'll take a look at actually, or next time, we'll take a look at actually using the content pipeline to pull in a tile map game. So we're actually going to create our own content pipeline classes to handle some of that. And that's all I have for you today, so have a good one.